For the subscriber, a mobile telephone call is a simple process. In reality, though, this call is only possible thanks to a complex network architecture consisting of various different network elements. In this lesson, you'll get to know the individual elements of the GSM network and their basic functions. The base station subsystem, BSS, provides the connection between the mobile stations and the network subsystem, NSS. The NSS forwards user signals to other mobiles via the BSS, or subscribers in the public switch telephone network, PSTN, and provides necessary customer data. The operation and maintenance subsystem, OMS, monitors BSS and NSS performance and remotely debugs occurring faults in the network elements. Additional components such as interface elements to data networks, the short message service center, or the voicemail system complete the GSM system architecture. The base station subsystem ensures as complete a network coverage as possible and includes a large number of structurally organized radio cells. It consists of the following elements: the base transceiver station, the base station controller, and the transcoder. The central element of one cell of this kind is a transmitting and receiving unit known as a base transceiver station, BTS. This makes the connection to the mobile station via the air interface and controls the transceiver, TRX. The transceiver, the central functional unit of the BTS, maintains calls to a maximum of 8 mobile stations via one frequency pair each. The BTS is also responsible for the monitoring of the signal quality and the encoding and modulation of useful signals. Via the ABIS interface, it forwards calls, signals, and control information destined for the OMS and the NSS to the base station controller, BSC. Several BTSs are controlled by the base station controller, or BSC. This assigns free radio channels in the TRX for the link to the mobile station. It controls the necessary output power for mobile station and TRX. It monitors the existing radio link to and from the mobile station and controls handover between neighbouring radio cells if they're under its control. During an existing radio connection, the BSC monitors its quality and controls disconnection of the radio link when the call is over. The BSC communicates with the transcoder, TC, via the ATER interface. The transcoder is the third element in the BSS and is needed to convert 64 kilobits per second original speech into a 16 kilobits per second signal of speech description parameters to ensure a spectrum-efficient modulation on the air interface. BTS, BSC and TC together form the base station subsystem, BSS. The base station subsystem forwards the signals to the network subsystem, NSS, where speech and circuit switch data are controlled and forwarded to other networks if necessary. The NSS provides data relevant to security and mobility. The speech signals processed by the transcoder reach the Mobile Services Switching Center, MSC, via the A interface. The MSC serves as a digital exchange for the forwarding of messages, connecting mobile subscribers with each other or with subscribers in other networks, such as the public switch telephone network, the ISDN network, or data networks. The MSC is responsible for the following functions. It forwards incoming and outgoing calls. It makes a connection to other MSCs in the same mobile radio network and makes connections with other mobile radio networks and to fixed networks. It monitors and controls the calls. It's responsible for call data acquisition and the forwarding of signaling information to connected registers or databases. In order to monitor, route and control mobile telephone calls in GSM networks, several registers are connected to the MSC. One of these registers is the Visitor Location Register, VLR, which is usually to be found in the MSC, but is a functional unit in its own right. It's designed as a dynamic subscriber file, with dedicated geographical areas of responsibility, the so-called location areas. The VLR acquires the data of all GSM customers in its areas, and is always well informed of their whereabouts. It assists the MSC in the acquisition of charge-relevant data with subscriber information. The bills are prepared from these data in the billing center. But where does the VLR get the GSM customer data from? For GSM customer data acquisition, there is a register, the so-called Home Location Register, HLR, in which each network operator registers the customer data necessary for dealing with traffic. The HLR supplies these data to all VLRs in which the GSM customers involved are to be found at any given moment. Inversely, the VLR in question informs the HLR of the location area of the customer, and is thus able to give routing information when calls come in. The HLR data contain information on access rights with regard to roaming, service rights with regard to voice, fax and data services, and additional subscribed services. The Authentication Center, AUC, contains the customer data necessary to protect connections against unauthorized access, and is mostly integral to the HLR. The AUC checks the information stored in the subscriber identity module, that is, the SIM card, for correspondence with its own register. If the data proves to be identical, the authentication of the subscriber is successful and he's given permission to enter the network. If the SIM card is stolen, authorization to access the network is disabled very easily via the AUC. Additionally, the AUC provides necessary information to cipher the air interface. The Equipment Identity Register, EIR, can be implemented as an option by the network operator. The EIR permits the detection of stolen terminal equipment used in GSM networks by checking the IMEI, International Mobile Equipment Identity, against the data stored in the EIR. This check is carried out independently of the SIM card and only applies to the mobile station in question. All the components which control and forward the call and are responsible for security and mobility management, that is, the MSC, HLR, VLR, AUC and EIR, form the Network Subsystem, NSS. The GSM network is monitored and controlled from a central point. This is the Operation and Maintenance Center, OMC. The OMC has the following tasks. The Fault Management System analyzes alarms from the BSS elements. When faults occur, they're eliminated when necessary via software command or in situ by technicians. The Configuration Management function installs the software when new BSS network elements are implemented, manages hardware inventory lists, and changes operation parameters, for example, for radio frequencies of a BTS. The Software Management System feeds in new software, or updates and manages the software inventory lists. The Network Management Center, NMC, assumes special functions in the context of OMS, which are not defined in the GSM standard, but are based on definitions of the International Standardization Organization, ISO, and on recommendations of the International Telecommunication Union, ITU. An NMC carries out functions of performance management. Alarms and fault elimination times are evaluated statistically. Capacity bottlenecks in the network are detected, and the service quality is monitored, for example, the dropped call rate in %. Depending on the network operator, the NMC functions are carried out in a centralized or decentralized way in the geographical areas. all NMC and OMC of a certain defined geographical area form the third subsystem, the Operation and Maintenance Subsystem, or OMS. The three subsystems BSS, NSS and OMS are vital for the operation of a GSM network. The interfaces within and between the subsystems are mostly specified by the ETSI. For dealing with customer support and supplying certain services, GSM includes a number of additional components. The Administration and Billing Center, ABC, transfers customer data to the appropriate registers of the NSS and into the AUC and the HLR. The Administration Center is connected to the Personalization Center for SIM cards, PCS, via an interface. This makes it possible to disable the SIM card if necessary and protect it from abuse. The so-called call detail records are used in the billing center for bill preparation. The voicemail system, VMS, is a memory system for voice, data and fax messages spread over the network. In other words, a large-scale answering machine. If a subscriber has switched off his mobile station or can't be reached for other reasons, the messages are not sent to his mobile station, but are fed directly into the VMS and stored there. The subscriber can either request them from the VMS or he's notified via SMS. The VMS can have interfaces to several MSCs and to the Short Message Service Center. Via the Short Message Service Center, SMSC, network operators, service providers and private customers can send short messages directly onto the mobile station of any subscriber. In the SMSC, the short messages are stored temporarily and forwarded to the recipient. Point-to-point short messages are alphanumerical messages with a maximum basic length of 160 characters, which are entered directly via the keyboard of the mobile phone. Compression and concatenating techniques increase the number of transmitted characters. The cell broadcast SMS, that is, the service offering point-to-multipoint short messages, is a one-way communication from the network to all mobile phones in certain geographical areas. The messages, with a basic length of 93 alphanumerical characters, are entered in the OMC, fed centrally into the BSC, and transmitted to the mobile stations via all connected BTSs at regular intervals. In order that data can be fed into the GSM network from packet switch networks, such as the Internet or company intranets, a so-called interworking function, IWF, is required. This is an external data server connected to the different data networks. The IWF translates the unstructured incoming packet switch data into circuit switch signals which can be understood by GSM. A firewall upstream of the IWF protects the GSM network from unauthorized access by hackers. In GSM Phase 2, only circuit switch data services are supported. The interworking function, IWF, integral to the MSC, connects the circuit switch GSM data traffic to the existing packet-oriented networks, in other words, the Internet, corporate networks, public data networks, and WAP servers. It converts protocols and adapts the data rate for the BSS. In GSM, the Public Land Mobile Network, PLMN, is a cellular network with a hierarchical structure. The smallest unit is the radio cell, which the BTS supplies with frequencies, or, in other words, radio channels. It provides the network coverage. Several radio cells are put together to form administrative areas controlled by a BSC. Various areas controlled by one BSC each form a location area controlled by a VLR. It's also possible for a location area to cover one BSC only, or even one cell if reasonable. If a mobile phone subscriber changes to a new location area, a location update takes place automatically. So the location of the subscriber is known to the network via a VLR linked to the MSC. If a BTS is in the centre of exactly one cell, we speak of an omnidirectional radio cell. The BTS transmits its frequencies with omnidirectional characteristics and a high output. Omnidirectional radio cells are used particularly in relatively sparsely populated rural areas. In densely populated areas, though, the network must supply higher capacities. One way of doing this is the sectorization of radio cells. With a sectored radio cell, the BTS can supply up to 3 radio cells in 3 times 120 degrees with several frequencies each. On motorways, base transceiver stations are preferentially configured in 2 sectors. For example, the BTS transmits frequencies in 2 times 180 degrees. The cell is aligned along the course of the road to be covered. In densely populated cities, we often find a combination of omnidirectional cells and sector cells. This is because there can often be zones of missing coverage between sector cells. A superordinated omnidirectional umbrella cell takes over the radio supply for scattered individual mobile stations located in these locally occurring receptionless zones, and for rapidly moving mobile stations used on motorways and in high-speed trains. Rapidly moving mobile stations in particular are supplied via the larger umbrella zones in order to avoid as far as possible handovers taking place in rapid succession. In order to supply areas with a large number of mobile phone users, so-called microcells are used. Thus, for example, BTS with a low output are used in underground stations. These take over the radio supply on the platform or, with special antennae, in the subway tunnels.